Hi friends, in this video we are going to solve these two problems. So here f of x equal to root x and g of x equal to 1 by root over x prove that the C of the Cauchy mean value theorem is the geometric mean of a and b. So here geometric mean of a and b for a comma b is strictly greater than 0, and in the same way f of x equal to e power x and g of x equal to e power minus x prove that the C of Cauchy mean value theorem is the arithmetic mean of a and b. So for a comma b is strictly greater than 0. How to show is the following with the help of Cauchy mean value theorem. So here the working rule of the Cauchy mean value theorem says first we have to check whether the given functions are continuous f and g. Second thing, you have to check f and g are differentiable. Third, g dash of x is not 0. Then apply the Cauchy mean value theorem. Find c by using f dash of c by g dash of c equal to f of b minus f of a divided by g of b minus g of a. So we have to find the value of c. With the help of this, if the value of c is the geometric mean of a and b, then we get the result. Regarding this problem, is the geometric mean of a and b, is the c is the arithmetic mean of a and b. That is, arithmetic means we have to for first problem we have to show c equal to root over ab. So that is the geometric mean of a and b. And for second question we have to show c equal to a plus b by 2. That is the arithmetic mean of a and b. This is the geometric mean of a and b. So we have to show c equal to root ab, geometric mean of a and b, and we have to show c equal to a plus b by 2, which is the arithmetic mean of a and b for example 2. So here how to prove is the following. Now tell me, so here first I will prove the solve question 1. So here first one answer. Here f of x given thing which is equal to root over x and g of x which is equal to 1 by 2 root x. So here f of x equal to root x and g of x equal to 1 by root x, which is defined on here defined on the closed interval, let's say a to b. Here a comma b is strictly greater than 0, means in this interval both a and b are strictly greater than 0, means let's say this is the positive x-axis. Let's say just for the sake of understanding. Now here we can take 1 to 2 or 2 to 3 closed interval. Now first condition, so here this is the answer here. Now first condition of the rules Cauchy mean value theorem says check the given functions are continuous or not. So here f of x equal to root x and g of x equal to 1 by 2 root x is continuous on the closed interval ab as a polynomial function in x. So here first condition is satisfied. Now tell me the second condition. First we have to find the derivative of f of x and derivative of g of x. So here f of x equal to this, therefore f dash of x equal to 1 by 2 root x, and derivative of g of x, that is g dash of x equal to 1 by 2 x to the power 3 by 2. So here this is the derivative of f of x and this is the derivative of g of x. So here root x, here f of x can be written f of x equal to x to the power 1 by 2. Therefore here f dash of x equal to 1 by 2 times x to the power 1 by 2 minus 1, that is minus 1 by 2, which is equal to 1 by root x. So here first is okay. Now tell me g equal to, here x to the power minus 1 by 2 can be written here. Therefore g dash equal to minus 1 by 2 times, so x to the power minus 3 by 2, which is equal to minus 1 by 2 x to the power 3 by 2. So here that is minus 1. So here derivative of f of x is 1 by root x and derivative of g of x equal to minus 1 by 2 x to the power 3 by 2. So here now a comma b are strictly greater than 0, so there is no 0. So here this both the function f dash of x and g dash of x exist, because here only at 0 this function is not defined, except 0 this function is defined everywhere. So but 0 is not there in the open interval ab, because a and b are strictly greater than 0. Therefore here f dash of x and g dash of x exist for all x belongs to the open interval a to b. Therefore we can say, therefore f of x and g of x are differentiable in open interval a to b. So second condition is also satisfied. Now tell me the third condition. Here g dash of x equal to here minus 1 by 2 x to the power, this is 3 by 2. Now here this is never 0 because here in the open interval a to b 0 is not there. So here which is not 0 for all x belongs to the open interval a to b. So here according to the Cauchy mean value theorem, so here there exists c, therefore there exists c belongs to the open interval a b, because here the given pair of functions satisfy all the condition of the Cauchy mean value theorem. So there exists c belongs to open a b such that here f dash of c divided by g dash of c equal to f of b minus f of a divided by g of b minus this is g of a. So here now tell me, here I will write answer here. Now f dash of x equal to 1 by 2 root x, therefore just replace c by x, therefore f dash of c equal to 1 by 2 root c. So here 1 by, here I will write 1 by 2 root c. Now tell me g dash of x equal to this, therefore g dash of c equal to here minus 1 by 2 c to the power, this is 3 by 2, which is equal to, now f of x equal to root x, therefore f of b equal to this is root b minus root a divided by here g dash x equal to 1 by 2 root x, g of b equal to 1 by root b minus 1 by root a. Now here I will take the reciprocal, so here 1 by 2 root c, here I will write this root c as just c to the power 1 by 2 into this is 2 c to the power 3 by 2 divided by this is minus 1, which is equal to, just I will take here denominator of denominator is numerator. So here denominator of denominator is the numerator and this is denominator. So 1 by 2 c to the power 1 by 2, 2 c to the power 3 by 2 minus 1. Now here 2 gets cancelled. Here I will write this is root b minus root a divided by this is root a minus root b divided by root a into root b. Now so here c to the power 2 gets cancelled, c to the power 3 by 2 minus 1 by 2. So here c to the power 3 by 2 and I will take c to the power minus 1 by 2, which is equal to root here and divided by this is minus 1, this is root b minus root a divided by, here I will take minus from here, minus root b minus root a divided by this is root ab. I will write this root ab as here. So here this is root a b. So here numerator denominator of denominator becomes numerator. So I will write here this is root a and root a into this is root b. So here root a by root b. So here root a by root b. So I will write later, here I will take just minus sign. Now here minus minus gets cancelled, this minus gets cancelled with this minus. Now c to the power 3 by 2 and minus 1 by 2. So here c to the power 3 by 2 minus 1 by 2, 2 by 2, which is equal to root, here this root b minus a, root b minus a gets cancelled. This is root a into root b here, which is equal to c to the power 2 by 2 c, which is equal to root a into root b. So here a and b are strictly greater than 0, root a into root b becomes root ab. So this, therefore c is the geometric mean of a and b. Hence therefore c is a geometric mean of a and b. Hence we have to show here c of the Cauchy mean value theorem is the geometric mean of a and b. That's we have to show. This is the answer of question 1. So now we have to show f of x equal to e power x and g of x equal to e power minus x. Prove that the C of the Cauchy mean value theorem is the arithmetic mean of A and B. How to show is the following. Now, I hope all of you write this. So here I don't have space. I will remove this. Now, here given question number 2, given f of x equal to e power x and g of x equal to e power minus x, defined on here, defined on, let's say, the closed interval a to b with a comma b strictly greater than 0. Now, so according to Cauchy mean value theorem, first we have to check. So you have one, f of x equal to e power x and g of x equal to e power minus x, as the exponential functions are continuous. So here these are the exponential function, both f and g. So here as an exponential function, both f of x and g of x are continuous on the closed interval a to b. So here is a continuous on the closed interval a to b as a exponential function, let's say exponential function in, let's say, x. So here first condition is satisfied. Now tell me the derivative of f of x. So here derivative of f of x, that is f dash of x equal to derivative of e power x is simply e power x, and derivative of g of x, that is g dash of x equal to e to the power minus x into this is minus 1, which is equal to minus e to the power minus x. So here and a comma b strictly greater than 0. So therefore f dash of x and g dash of x are exist for all x belongs to the open AB. Therefore f dash of x and g dash of x exist for all x belongs to the open interval a to b. Therefore f of x and g of x are differentiable in the open interval a to b. So here both f of x and g of x are differentiable in the open interval a to b. Now tell me the third thing here, g dash of x, which is equal to minus e power minus x, which is never 0. So exponential function which is never 0 for all x belongs to the open interval a to b. So here the graph of e power x is reverse of e power minus e power x, that is e power minus x. So here this is never 0, never touch to the 0. So g dash of x is not 0 for all x belongs to this open interval AB. So here according to Cauchy mean value theorem, we have to find the value of c by using this and show that c is the arithmetic mean of a and b. Now therefore here by this function f and g satisfy all the condition of Cauchy mean value theorem. Therefore by Cauchy mean value theorem, there exists c belongs to the open interval a to b such that f dash of c divided by g dash of c, which is equal to f of b minus f of a divided by g of b minus this is g of a. So here now tell me f dash of x is already we have find. Now tell me just replace c by x. Now tell me f dash of x equal to, so here f dash of x equal to e power x. Therefore f dash of c equal to, so here just replace c by x e power c divided by g dash of c equal to g dash of x equal to minus e power minus x. Therefore g dash of c just replace minus e power minus c, which is equal to f of x equal to e power x. Therefore f of b equal to e power, this is e power b minus e power a divided by here this is e power minus b minus e power minus a. So here e power, so here this is equal to e power c here, and here I will take this minus e power here I will take this minus here, and this is e power minus divided by minus c becomes here this is e power c, which is equal to e to the power b minus e to the power a. Now here I will write this as 1 by e to the power b minus 1 by e to the power a. Now here minus e to the power this is 2c, which is equal to e to the power b minus e to the power a divided by, this is e to the power a minus e to the power b divided by e to the power b into e to the power a. Now here minus e to the power 2c, which is equal to e to the power b minus e to the power a divided by, here I will take minus sign, minus times e to the power b minus e to the power a, the denominator of denominator becomes numerator, which is equal to e to the power b e to the power a. Now here minus minus gets cancelled, e to the power 2c equal to, here this e to the power b minus e to the power a cancel with this, so e to the power a into e to the power b, here which is equal to e to the power a plus b. So therefore 2c e to the power 2c equal to e to the power a plus b, therefore e to the power 2c equal to a plus b. This implies c equal to a plus b by 2. Hence c is the arithmetic mean of a and b corresponding to these two functions f of x e power x and g of x equal to e power minus x. Therefore c is a arithmetic mean of a and b. Hence the result. That's we have to show. Thank you.